Hi, in this video we're going to learn about exponential functions and their graphs. At the end of the video, you should be able to graph exponential function. Let's start with definition. The exponential function f with base b is defined by the function formula f of x is equal to a times b raised to x, where b is the base and x is an exponent. Another condition, b is greater than 0 and b is not equal to 1, and x, which is your exponent, is any real number. A is any number as well. But we're going to focus on b. There are two possibilities. If b is greater than 1, such as 2, 3, 4, and so on, or 2.5 and 3 point something, b is considered growth factor. Another possibility is that b is less than 1 but greater than 0, which means it could be decimal like 0.1, 0.2, 0.5, or fraction 1/2, 1/4, 1/8. If that is the case, b is considered a decay factor. This terminology, growth factor and decay factor, will make sense when we have a specific example. Here is your example. F of x is equal to 3 raised to x, and another example function, g of x is equal to 0.5 raised to x. The first example is an example of a growth factor wherein b is greater than 1. The second example is an example of a decay factor where b is between 0 and 1. Either way, they are called exponential functions. Let's have the evaluating function. If you have an f of x is equal to 3 raised to x, when x is equal to 2, what do? 3 raised to 2 is just 9, because 3 times 3 is 9. The same function, if x is negative 2, remember, if you have an exponent of negative, the whole thing flips. The rules, according to your laws of exponent, any number raised to a negative exponent will be written as 1 over that value with the same exponent, but it becomes positive. That explains 3 raised to negative 2 becomes 1 over 9. The same, no, it's not anymore the same. What if you have a 0.5? The function g of x is equal to 0.5 raised to x. When x is equal to 4, what do? It's gonna be 0.5 raised to itself or multiplied to itself 4 times. The number becomes smaller and smaller. From 0.5, it became 0.0625. 0.5 square is actually 0.5 times 0.5, it's 0.25. Does that make sense? If a number, or no, if the b, base b, which is having an exponent x, is between 0 to 1, which is decimal or a fraction, the result tends to become smaller and smaller if your exponent goes higher. That explains the decay. Here, as you substitute higher number x, the result will just become bigger and bigger. That explains why b here, which is greater than 1, is a growth factor. Okay, now let's have the graphing. How do you graph? If given the function, there's no a, there's no multiplier, and if b is greater than 1, this is the expected graph. It is expected that the graph will cross or intercept, the graph will have a y-intercept of 1, because remember, any number raised to 0 is equal to 1. So that explains the graph will cross at or intersect at y1. If your number goes higher, the graph will just go higher and higher. Now, another thing we need to remember, if you are being asked what's the domain, checking at the graph actually extends both to the left of x-axis and to the right, both left and right. So therefore, domain is from negative infinity to positive infinity, because domain is all about how, or did the graph extend to the left of x-axis, or did it extend further on the right side of x-axis. Next, if you have a domain, what is range? Range is a little different. If you're going to check and have a specific example of this graph and try it on a calculator, the graph seems to go closer and closer to x-axis, but it doesn't touch the x-axis. So we could presume that the range is going towards 0, but 0 is not part of the range, and it goes further to positive infinity. This graph will just extend slower and slower going to the right, but this graph on the left will just seem to extend forever, but it seems like to go approach closer and closer to x-axis, but it does not meet it. That is one of the special property of exponential function, which is called asymptote. Here in this case, this graph seems to get closer and closer to the 0 of y line, and that is your horizontal asymptote. Asymptote is a line that continually approaches a given curve but does not meet it at any finite distance. Okay, you can actually go check it to your calculator, graphing calculator, and zoom in. The line will just keep approaching 0, but it does not intersect it. Okay, now what if your b, which is supposed to be your decay factor now, but b can never be negative? So if b is between 0 to 1, what happens? This is how your graph is supposed to look like. Again, if x is 0, y is 1. It always intersects here if there is no number in front of a. Now, of course, as you can see, domain is going to be the same. It will extend both left and right. The thing is, if you remember, the graph earlier is going on the other side. It approaches to 0 on the left side, but it goes up and away on the right side. If you have a decimal between 0 to 1 as base b, or a fraction less than 1, the graph seems to go the opposite way. It goes up on the left side and it slowly goes down and seems to approach the x-axis, which is the y line horizontal. Still, it's the same domain, but the range is also the same, except that their trending line is different. The same asymptote, but the asymptote is going, the curve asymptote is created approaching to the right. Going back to your previous, the asymptote is created because the curve seems to approach the asymptote line towards the left. Okay, so those are the two cases. Another thing you need to realize is that the decay makes the graph go lower, and smaller and smaller and smaller. That's the decay. On the other first one, the growth factor, the graph goes higher. The y, the range just becomes bigger and bigger. Okay, that's their main difference. Now, Let's have another example. This time we have a specific example with a given base. This is supposed to be a power. Now, you have here the function f of x is equal to 2 raised to x. Let's begin. If x is negative 2, 2 raised to negative 2 is 4, but since the exponent is negative, it goes down below 1, so it's 1/4. Negative 1 is going to be 2 raised to negative 1, it becomes 1/2 because it becomes a fraction, 1/2. If x is 0, remember the graph a while ago, any number raised to 0 is 1. If x is equal to 1, then the function is equal to 2. If x is equal to 2, therefore 2 times 2 is 4. Now, this is the first point on if x is negative 2, y is 1/4. If x is negative 1, y is 1/2. If x is 0, it crosses at 1, intersects at 1. If x is 1, y is 2. If x is 2, y is 4. And that's your graph. Remember, the graph will seem to intersect the x-axis, but it does not. And that's what you call asymptote line, an imaginary line where the curve seems to meet, but it does not meet it, or it does not intersect. Now, for our domain, both sides extends on both left and right, so you have from negative infinity to positive infinity. The range, it starts from 0. It tries to approach us from 0, but it does not touch 0, so we use parentheses 0 going to positive infinity, and that's your range. And that's how you graph your exponential function. This should be power of x. Now, let's deal with what if your function has different values. We are now dealing with translation. So the same graph a while ago, 2 raised to x, but this time with -1. What happens? Remember, in your transformation, the graph will just seem to, there is a y-intercept now, which is going to be somewhere, not actually -1, because if there is no -1, the y-intercept is at 1. Actually, the whole graph will go 1 unit down. So the translation here is the graph goes down 1 unit. So since if there's no -1, the line is supposed to intersect at 0, 1. But since there's a -1, the whole graph will just go down 1 unit, and that's one example. This is our first example of translation, and this is your graph of 2x minus 1, the black curve. Of course, the domain and range, no, actually only range will change. Domain is from negative infinity to positive infinity. The range now will start from -1 going to positive infinity, because the asymptote is your starting parenthesis border of your range, from -1 going up to positive infinity of y. Range is y. Now, what if your exponent is a negative? How does it change the graph? Actually, here's a hint. It's a reflection of graph. If you are going to graph, the graph of this function is a reflection in the y-axis. It means the graph originally of the 2x is going like this. It will just flip with respect to y-axis. That's the case if you graph the parent function 2 raised to x, raising it to a negative x. The graph will just be a reflection over y-axis. Next, domain and range will be the same for both original and your negative x. Let's have some more example. Sketch the graph of g of x is equal to 4 raised to x minus 3 plus 3. So we're going to construct the table now and substitute or select numbers for x's and solve for y. So let's start with 1. If x is 1, 1 minus 3 is negative 2. 4 raised to negative 2. Let me show the work, and so it's easier. So if x is 1, 1 minus 3, it becomes negative 2. Remember, if it's an exponent, it's supposed to be 1 over 4 squared. 4 squared is actually 1 over 16. 0.6 or 1 over 16 is actually 0.0625 plus 3 because you're going to add 3. Okay, now if you have 2, let me fix it. 2 should be easier because 2 minus 3 is just gonna be 1, actually negative 1. So it's gonna be just 1 over 4. 1 over 4 is 0.25, and 0.25 plus 3 is 3.25. 0, if x is 3, 3 minus 3 is going to be 0. Let me clear. This is gonna be your last example, I think. So if x is 3, 3 minus 3 is 0, 4 raised to 0 is 4 raised to 0 is equal to 1. 1 plus 3, 3 comes from the original function, the result is 4. That's why it's 4. Any number raised to 0 is 1. Now what if it's 4? Well, x minus 3, if x is 4, 4 minus 3 is going to be 1. 4 raised to 1 is equal to 4, plus 3 is 7. What if x is 5? 5 minus 3 is 2. 5 minus 3 is 2. 4 raised to 2 is 4 squared. 4 squared is 16. 16 plus 3 is 19. But this is already way beyond and away from our graph. So it may make sense to have lesser number or consider picking your values of x. If you have more than 10, it's definitely going to be away from your graph, or you can adjust your graph correctly. Now let's graph the point. At positive 1 is 3.0625. No, yeah, 3.0625 is just above 3. And then if x is 2, it's 3.25, almost half. And if x is 3, it's going to be on 4. If x is 4, y is 7, it's actually up and away here. So just to graph the curve, here it is. And remember, there is supposed to be an asymptote. 5 is already way away, really away from the graph. Remember, there is an asymptote. Asymptote is a imaginary line wherein the graph seems to intersect it, slowly approaches it, and seems to intersects it, but it does not even meet the asymptote line. But the asymptote line is your boundary of your range. So domain is always going to be all real numbers, and range starts from the asymptote, which is y is equal to 3, going to positive infinity, or in a simple inequality, y can only be in this function greater than 3. And that's how you graph your exponential function. At the end, you should have learned how to correctly graph your exponential function. You can watch the video again and review the parts that you think you need to watch again. Thank you.